So transformer, basically it consists of two main parts, core and winding. So let us see the drawing of core and various parts of core. Now this is your stamping, and we know that core is made up of stampings. This is done to avoid to minimize eddy current loss. Now this is called window. This part is called window. So in question they will give the dimensions of window. So they will give what is the length and what is the height of window. So window will be given. This is called limb. So we know that the transformer has two limbs. This is one limb and this one is another limb. Then we have yoke. This is called yoke and this is called yoke. So we have limb, we have upper yoke, lower yoke, and these two are limbs. This is called window, and this is the center of limb. This is center of limb. They will give the distance of center to center distance. So center to center distance between limb. So this is first limb, this is second limb. Take the center of these two limb. Center to center distance also will be given. And they will give what is the width of yoke, what is the width of limb, and also this part is called height of yoke. Height of yoke, or they may say the width of yoke. So this is the height of yoke. Then this part is called height of core, that is window. Height of core is this part, and this part is called height of transformer. So from this point to this point is called height of transformer. So these are the some of the things or some of the parameters in which the core can be constructed. Now winding is placed in this limb. So if it is single phase winding, so first comes LV winding, then comes HV winding. Now how to draw the winding? What we have to do is drop these lines from the limb, drop this line. So this is a side view, this is top view. So we have a here winding also. Winding I'm drawing here, then I will take it on this. This is called core. So this is top view. We will have a core. So what is the width of largest stamping will come here. And then this circle is the diameter of your core. So if you know length and width of this stamping, we can find out the diameter of this core. The first comes LV insulation. After the core, the first comes LV insulation. So I'll do like this. This is LV insulation. So first comes LV insulation. This is LV insulation. I'll write here LV insulation. First, always low voltage winding is done and with their insulation. So first comes with the core is LV insulation, then comes LV winding, so this is LV winding. So first comes core, then comes LV insulation, then comes LV winding. Once LV winding is done, next comes HV insulation. So next we will have HV insulation. So HV insulation. So I'll mark it with the red. Right. So I'll repeat again. First comes core. The core diameter and will come from core details. So first we have LV insulation, then we have LV winding, then we have HV insulation, and then we have HV winding. So this is HV winding. Now I'll take this projection. This is only one limb. This is only one limb cut section is given. Now I'll take this projection upward. So what we get is take all these projections, all projections you have to take insulation, HV insulation, LV winding, HV winding, all these lines you have to take projections. Now first was LV insulation. So so the first one gives you LV insulation. So this I'll mark it with yellow. Then comes LV winding. So same line you have to draw LV winding both side. Then comes HV insulation, and then comes HV winding. HV insulation, then HV winding. And this is wooden piece here. This is wooden piece. So if wooden piece is kept, this is HV insulation. So this is your left half cut section. Similarly, this winding will be here also. So this is left half cut section. So what we have is there are four important things here. We have LV insulation first. It is touching the core. Then we have LV winding. Then we have HV insulation. And then we have HV winding. So they will give the diameters of these windings. So it must be drawn here first. Then from here, you have to take the lines and draw here. And this in this they will give you height of winding also. So this is the height of the winding. Whatever the left place is there, you have to mark a, for a wooden piece. So the wooden piece is kept to tighten the winding and also for insulation purpose. So this is single phase transformer. Similarly, we have here also. So if it is since it is only cut section, So we have to draw the outer part. So cut section of only left half cut section, or they may ask what is the right half cut section. So this is the way a transformer is drawn. So this problem has two-step core. Now you can see the width of smallest stamping, which is given as 175. So this is the width of smallest stamping, 175 mm, and also given is width of largest stamping is 280. So from this point to this point is 280 mm. So width of this is 175 and width of this is 280. This is given, right? Now what we can do is we can take this extension and the question is write. So you have to do the right half in section. So right half or left half, no problem. I'll take the extension of these lines. So now what is given is yoke height. Yoke height is 250 mm. So we can start with a line and we will have the height is given. This is 250. So I'm doing left half section. So yoke is already given. Now yoke height is done. Next, yoke length is given 770. So height of the core is given 430 mm. So from here we will have a height and this distance is 430. This is core. This is given. Now this is 250. Next, distance between the two centers of core is 490. So take the center of this and measure the distance of 490. This is the center of this one. So this core and this limb center distance is 490. Height of core is given 430. So this is my core, and we will have a winding around this core. So from center, measure the same distance. So whatever width, that is 280. So take 280 and we can do right side also. Now we know the yoke width 250. Height of this core is 430 given. Center to center distance is 490 given. Total height of the transformer. Total height of the transformer is also given. So this is 930. So 430 plus 250 plus 250 is 930. That is the meaning. Now this yoke length is given 770. Now let us start with LV winding. So it is already given. There's inside diameter is given. You can see inside diameter of LV winding is 337 mm. So what we can do, this as a center. First, I'll draw this circle. This is core diameter. Now, how to find core diameter? So what we can do is, we have to find this line. This can be found using 175 square plus root of 175 square plus 280 square. So when you do this, you will come to know the diameter. So inside diameter is square root of 170. 175 square plus 280 square, 330. So the core diameter is, I'll write this, core diameter is 330. Core diameter is 330. So from this as a center, let us draw. It is given inside diameter of LV winding is 337. So this is 330, the core diameter. How we got core diameter? 175 square plus 280 square root of this will give you the diameter of core. Now inside diameter of LV winding is 337. So take this as a center, draw a circle with 337.5 mm. So you draw a circle. Yeah, this is inside diameter of LV winding, and this is how much? LV winding 337.5 mm. Then given is outside diameter of LV winding is 383. So I'll draw one more circle. With this is LV 383 mm. So with these two things only, I came to know what is LV insulation. So this is my LV insulation. So 330 minus 337 will give you LV insulation. So this part is my LV insulation. And this is LV winding. So LV winding is done. Now let us see HV winding. Again, we can see HV winding. It is divided into two layers. So we have two layers of HV winding. The first inside diameter is given 415. So from this as a center, draw a circle with 415 mm. So that is the first layer, and outside diameter of first layer is 433. So draw a circle again with 433. So this becomes my HV first layer. So I'll mark the insulation part. This is HV insulation. HV insulation. So let us mark now. This circle is HV layer and it is 415. This circle is first HV, first layer, and it is 433. This is HV insulation. Now let us see the second layer. We have a second layer. The diameter, inside diameter is given 450. So draw one more circle with the diameter of 450. This is inside diameter, and outside diameter is 468. So we have one more insulation, HV insulation. So this is my second HV. So second HV diameter is 450. This is outside diameter of second HV layer, that is 468. So this is how the winding has to be drawn. And since you know the inside and outside diameter, uh, in CAD it is very simple. Keep drawing the circles. Now I will extend these things. So from the edge of these circles, please draw the extension lines. So what I'll do, I'll take the last one, and here the last one. Then all the lines you have to draw in such a way that all LV winding, HV first layer, HV second layer can be drawn. Now they've given height of the LV winding. So they have given height as 362. So from this, take as a center, draw a line. So this distance is 362. So this distance has to be 362. Now the first comes your LV insulation, then second comes LV winding, then comes HV insulation, HV first layer, HV insulation, then comes like this. So you have to hatch whatever you have done, keep the same hatch here also. So first comes, this is your LV insulation, then comes LV winding, then comes HV insulation, HV winding, then second layer insulation, and then we have HV second layer. Now in a similar way, you have to draw here. First comes LV insulation, LV winding, HV insulation, HV winding, so we have height here, height is given, height of winding is given. Now I'll mark insulation, LV insulation. Then we have this is HV first layer insulation. Then we have second layer of insulation. So this is how a transformer cut section is done. And now the other side, we can complete this is other side, that is not cut section. And similarly here, this is your core, and you will have